smarter than me. There we go. I wondered why I didn't echo. So, as I said, I was a camp counselor for a long time, so, big parade fields, etc. And what I do is I work for Red Hat. I'm this kind of new thing called a developer advocate or a developer evangelist. And so I've spent, about 15 years mostly as a software consultant. So a lot of different projects, mostly kind of big enterprise sort of things. And now what I do is I talk to kind of developers who use kind of Red Hat products, in particular Enterprise Linux, talk to them about what they hate about it, and then I go and talk to engineering about how we can fix that stuff. So that's mostly what I do. And that's a little bit about me. So this talk is actually, it's kind of essentially about this concept called software collections, but I come definitely from the developer background rather than coming from like a packager's background. So I think I have a lot of biases towards being a developer and, not needing things like QA or, any release stuff, and we'll just send it out there and everything will be fine. No security updates, etc. But so just a little bit of, on me. So here's a little bit of my argument. Over the last, 15 years, Linux distributions, they kind of started in this kind of world where, the open source community was relatively small. Even proprietary software and open source software, neither one could you trust basically at all. It was all run by developers who didn't really know or care what they were doing, so things like security updates would never happen, QA if you were lucky, etc. So early on, I argue that the distributions kind of formed to try to basically solve some of that ease of use problem and kind of redistribution problem around security patches and software and kind of things like that, so that you kind of you knew where you could get stuff from, and you could also redistribute things so that they would stay secure. It was also kind of arguably earlier than that, but over the same 15 years or so is where kind of the dynamic linking concept really took off and caught on. There were definitely pockets before that, but it wasn't until, like 96, 97, where it was like, it started to become like the way to do things. And then the last thing was actually license assurance. This was much less of a problem with proprietary software, obviously, although in fact they were hugely violating licenses anyway, but you couldn't tell. But with open source, it was a big concern, right? So you wanted to make sure, particularly as open source started to be adopted by the enterprise, that you knew what kind of licenses you were getting into. Also, feel free to interrupt me. So you can tell me I'm crazy. If it's just blanket crazy, though, well, let's wait till the end. So particularly now in the last maybe 5 years, there's been, and I couldn't find a good graph for this. I've actually seen one before. I was talking about somebody earlier that, kind of just the package count in Fedora, each version is it's just scaling like crazy. Obviously in something like Enterprise Linux, we have significantly less packages, but even that is still a nice, strong curve. And so between that, now we also have a massive plethora of actual Linux distributions that are reasonably popular. So it's not, 3 big ones, right, and then everybody else, right? There's a good chunk at the top, right? And then Linux in general is also becoming hugely adopted, particularly in the enterprise, kind of in server rooms in particular, but then even to some extent in the enterprise on desktops. I don't think it's ever, I don't think we're ever going to see the year of the desktop, but it is in some places. I think it's largely going to be the only people who use kind of desktops, and by desktop I mean laptop half the time, are going to be people like you guys, right? It's going to be just developers, just people who actually make software who use these things at all, right? It's everything else is going to be tablets and and that kind of tool chain. So we really need to kind of focus on making sure that we can distribute things well. So here's the extent of the math I can do anymore. So we have a whole lot of projects, and then we have versions of each project, then we have it across distributions, and then we have versions of the distributions, right? So now we just made the thing massively wide, right? So kind of typically, we just do this kind of, take a tarball, right, and then kind of have to figure out the distro's packaging rules, and then kind of figure out how to build the thing itself, and then start to, kind of put that into a package. We got to follow these rules and make sure it goes in the right places, et cetera. And then on top of that, inside an individual organization, there may be kind of a second set, or third, or fifth, or 47th set of packaging rules within that organization. So you kind of have to solve the problem over and over again. So what would be a lot nicer is if we could kind of say, okay, I have this package, right? And if you saw, I don't know how much of Donnie's talk covered this earlier. I know he's covered it in the past, but whatever that means, right? So a package, but essentially, if we had a blob of thing that we could run, say, on any distro, right, that was OS independent, version-wise as well. So you could kind of go this way, right, for the package could drop on each one, or you could go this way, right? So version 2, version 3, version 4 of the OS. And then the other thing is, can you start to trust essentially the developers to have packaging rules that make sense, for their application, rather than it being a distribution problem. So lots and lots and lots of people have tried to solve this problem. Here are five that I thought of off the top of my head, and ones that I could find random, easy links for. Actually, I had Linux apps in there too, but I couldn't find a good place to point people at off the top of my head. So some of them solve the exact same problem. Some of them kind of take it from a slightly different perspective. So that's what I think is kind of interesting, is it's kind of, every piece of software anybody writes has trade-offs. And these people clearly were taking different trade-offs, right? So kind of the environment modules, SEP, and to some extent Gentoo slots kind of all take roughly the same set of trade-offs, very similar actually to software collections, where it's kind of like, I want to have multiple versions of the same thing installed on the OS at a time, and I want to rely on the user to choose between them when they're running applications. OS tree, relatively new thing that is really actually about, it's really about arguably supporting debugging. So you can take an entire set of binaries and kind of swap them out, in and out, and it's for, doing like debugging of GNOME, right? So it's not just one application. Yeah?
We're going to look at doing that for software updates from cloud.
Using OS tree?
Yeah.
So, mind you, GNOME, I think, has 3 or 4 different ones that all try to accomplish this goal. There's Glick 2, Glick, it's another one too. And then you have Update Alternatives, which is also trying to solve the same problem, but in a very different way, which is I want to be able to switch for the entire OS what the version of something is. So instead of per application, which is what these guys do, it's actually for the whole OS, right? And that can kind of cause some problems, particularly with something like Python, right? So you switch the version of Python in your OS on Linux, right? And bad things are going to happen. And like I said, there's lots and lots more. So taking some of that thought, right, and taking some of the, so Red Hat has a little bit of a problem where, particularly for enterprise Linux, a lot of our customers want to use whatever version of enterprise Linux that they're using forever. And I mean forever, right? Because, well, one of the reasons is because the application that they're running on it is working just fine, right? So why would they want to invest? Normally, what you have to do is you have to invest development and effort, QA effort, release engineering effort into modifying the application to be able to run on some future version of the operating system. If it's a junk application that just does what it does, why would you make that investment? So as a result, they instead yell at companies like ours, right, and lots of other ones. Microsoft has this problem in a huge way as well, as you all have, I'm sure, seen with their big EOL announcements. Every time they announce an EOL, and then I think it's like 5 times they EOL it, and then it'll actually die. So they have this huge problem as well. They do some other interesting things. Look up the Civilization fix, the video game Civilization, the fix they did in Windows sometime. So what a software collection tries to do is instead of having the application kind of natively touch the OS itself, let's put a layer in between it, put a layer of indirection in there, so that we can now take this blob that's in between. It might be Ruby, right? Or it might be kind of a full stack. So it might be a web server plus Rails and Ruby and everything else. But the idea is there is a blob that you depend on that's kind of generally above the actual OS and below your application. So that's kind of what a software collection is trying to do, is saying, okay, let's identify that blob and let's try to make that blob portable. So now what you can do is you can say, okay, I have this janky old Ruby app, let's say Puppet, that is running on Ruby 1.8, right? Why is it running on 1.8? The way I hear it is because Enterprise Linux 5 runs Ruby 1.8. And why is Enterprise Linux 5 running 1.8? Because Puppet runs. So, but any which way, the point is, you take any old application or older application, and what you can do is you can kind of say, here's this blob. I'm going to guarantee the API on the top of it, and then I'll change how it delivers that API underneath, so that it can be portable across multiple versions of the OS. You also have the problem the other way, right? So there's a lot of push for people to move to Python 3. However, not all the distributions are ready to make all the changes to be able to move to Python 3. So how do you start writing applications in Python 3 right now without the kind of borking your Linux? Well, one of the ways you can do it is with a software collection. So it's kind of, by the two examples I'm kind of giving, right, you can kind of see it's OS independent, right? The OS can continue on its merry way, and your application can decide to upgrade when it's ready. Or you can be aggressive and say, hey, I'm writing something bleeding edge, brand new, and I know I want to use the most cutting edge version of whatever because I'm not going to change it again for 10 years. So let me get that right now and use it right now to write my application. So kind of going into it a little bit more, so it really is, as it says, it's kind of defining a process a little bit more than a product. So it's kind of a conceptual thing. There is an implementation, but that's kind of what it does. The other big thing that it does is it packages outside of the normal kind of Linux file system. And that's sometimes a problem for some of the people, I think, in the room. It allows multiple versions to be co-installed, right? And then per application, you can essentially start, or you can say, this application gets this blob rather than that blob. So the way we kind of defined it is it installs under opt with, the L acronym that is the Linux naming that I can't actually say. You go register for a Linux name so that you can get kind of a short code there, and then you put your application name there. And that's kind of where it installs. And then you have kind of some scriptlets that know where that is and can provide that information to the application. And the way it basically does it is by fancy pathing, right? So the application doesn't have to know. This is the other, sorry, I didn't mention this part. One of the big differences between the ones that I was talking about earlier and this one is that the application doesn't have to know that it's not the base OS version, right? Which is, I think, hugely important because you don't want to have to rely on your average developer to figure out where it's going to be. And again, to allow for that OS independence, someday, right, all the Linux distributions will be on Python 3, and that will be what's at user bin Python. So what you want to do is be able to write the application and to say user bin Python at the top, and then it just goes to the right place rather than having to, do fancy symlinks or make a mistake and say, and have user bin Python 3, and then find out now you have to do engineering effort to port it. So in a little more detail, here is kind of the way the one for Ruby works that we have built. So here's kind of regular Ruby, right? Assuming that you installed Ruby, the other nice thing about this is that you don't actually have to have, I can't remember if Ruby is installed by default, but you don't have to have Ruby installed except for this particular application. So in other words, it doesn't have to be anything in user bin Ruby. It can just be down here. So I think it's pretty obvious, but basically here's the normal path, right? And here is our special path. We ship a Ruby 193 variant, one of these blobs. It sits under RH because that's our name, and that's pretty much all there is to it. This little script here is what does all of the magic, such as it is, which it basically kind of provides those paths so that the command to run these, which I think is down here, so SCL enable Ruby 193 bash. So what you do is you kind of say, here's the command, right, SCL, I want to turn it on, all right, and then which one do I want, Ruby 193, and then what do I want to execute with it? So if you just want to get a new shell back where Ruby 193 is available, you just run bash. But it could just as easily be, some app, right? So from a kind of, if you're a sysadmin, it would be like an app and then you put this in, a shell script or a start script or a something script. For a developer, he's going to drop into bash most of the time. You can add this to your .profile, and so it's just always there if you want as well. Then we talk about, there's basically some tools out there that kind of help make this stuff work. And so there's some links. I think all these slides are available somewhere. Joe would know better than me. I will email them to Joe. He will make them go. This is the ones that we've done already. Actually, it's some of the ones we've done already. We actually have some that are out there for like HTTPD 2.4. I can't remember what else is up there that's just kind of public. There are some other distributions that are related to ours that also have all of these. There's a guy, I think, who's talking next who had a hand in those. So I think they're well represented now, actually, in CentOS, Scientific Linux, and Fedora. Yeah. So Fedora just approved them, whatever it was, last week? Or was it the week before? Okay. Oh, okay. I can always pray. All right, so it's getting there. You can there is some of this stuff built for Fedora, but you can't get it in kind of the mainline distro repos yet. So that's basically most of my slides. I was expecting more interruptions. I invited hecklers, and they're not delivering. Exactly. That's true. That's true. So here's kind of my argument, right? And I'm probably crazy, but I think vendors in general are a lot more trustworthy. And when I say vendor, I mean proprietary software, I mean open source projects, I mean everything, right? Any kind of application. I think the distribution doesn't have to take on as much of a responsibility for making sure that all the stuff in the world runs. Yeah. Which is not a high bar, but let's say are reasonably trustworthy. So they're even more than that. They're that I think a lot of this stuff most people understand. Most people who do this kind of work, right? Most people, they understand what's important, how to break their things up. Yeah, there's still faults, but I think a lot of them are starting to get it. There's well-known libraries for particularly security-related things. So people mostly use those libraries. I think Bruce Schneier is finally getting through to people and saying, stop writing your own encryption libraries. So same kind of thing. So I think in general they're considerably more trustworthy, so that I don't necessarily think that every distribution needs to package everything under the sun. I also think another big reason, right, is kind of redistribution. One of the things that Software Collections has that kind of fails and goes backwards in time a little bit is it's a lot of things are considered to be statically linked, right? Because the only way you can be portable across OSs is if you carry the bits you need, right? So that means static linking, sort of, right? Or at least it means that it's got to be carried in the bundle. So it can still be dynamically linked. However, it's got to be dynamically linked from within this software collection. So one of the things that I was certainly confused about when I first looked at this stuff, so if you think about an RPM, one software collection does not equal one RPM, right? A software collection is more like 70, 1,000 RPMs. So it's broken up just like you would do a normal package. It's just that it's all kind of in this one context to say, hey, I'm part of this one software collection. So it is better, quote unquote, than straight out statically linking, but you still have the problem of redistribution. So one of the reasons that dynamic libraries are nice, right, is that you only have to copy that one file onto every machine. With a software collection, let's say it's OpenSSL, and you have 37 software collections on every machine, all using OpenSSL. Well, that means you have at least 37 different copies, right, of that SSL RPM. So you need to distribute that all the way through. However, and judging by the overflowingness of the config management talk, config management is really has really finally taken. I remember the fits and starts, right? I mean, there was a huge push for it, I think in around 2001, and just never quite took, but it's really kind of taken now. So I think redistribution, particularly in big data centers, has gotten a lot easier. So, I think that's why we can kind of take this risk. The other thing is, the other risk you have is that now you have 37 copies of OpenSSL. Disk space is not that big a deal anymore. So, does it really matter that you have lots of different copies of the same stuff on one machine? And deduping file systems someday, I pray, will be the default, and so it won't matter anyway. The other thing is that I think users are more sophisticated. So I think that they can they understand the context that they're, and when I say user here, I mean a developer, right? So somebody who's going to consume one of these software collections. They're way more sophisticated about what is going on underneath, and can usually figure this stuff out. Yeah?
I was going to say that the nature of the software collections does not mandate that you have 37 copies of OpenSSL. It may be that you require 3 specific compatible
right.
versions. And given that it's built on top of RPM, you can build an SCL on top of another SCL. So you could narrow that down manually as well.
So
you have to carry them all in the bundle.
I think dependent collections, right, are a very real and very important aspect of this that we're still working through some of the, there's I don't know where it's published right now, but we've been working on trying to get a good guideline for how to do dependent collections, right? So do you really want to do a Rails software collection? Well, not really, right? You want to do a Ruby software collection and then have a Rails software collection that depends on it, right? And what's the right size of a software collection, right? Should it be a full-on, kind of web server with, like I said, Ruby and Rails, or should it be, piecemeal? And I think a lot of those questions, I think, are yet to be known. The other thing I think that is going to be interesting about this is kind of the move towards containerization, right? So containerization, and I'm using that term to mean to be as far away from possible from any individual implementation, right? So you have things like Docker, you have LXC, you have this combination of we use an OpenShift, which is like C groups and SC Linux. You have actually much older and much more sophisticated versions in other operating systems that are not Linux. But the kind of this containerization concept where now we kind of say, hey, this whole application is now a blob and it's portable and we can run it into certain kinds of conditions and it can be updated on its own. I think that's going to be the next step for some of this stuff, and I think a lot of that will rely on something either exactly like software collections or something very similar, because it allows you to kind of bring that bundle inside your container.
You ready for questions?
Yeah.
All right. I've got a mic, so if you have questions, raise your hand. We'll bring the mic around so it turns up on the video later.
One thing I didn't follow, if you've got 2 software collections installed for 2 different versions of something, say Ruby, what's the mechanism by which the application gets to use the appropriate version.
So this versus like update alternatives. So the question was basically like, how do you say, I want this application to use Ruby 1.9 and that application to use, Ruby 2, right? So this, of course, is only at the very bottom of the screen here, so you probably can't see it. I should have probably put it at the top somewhere too. But this, unlike say like update alternatives, you tell the application which one it's using, or the application doesn't actually know, but you say SCL enable whatever collection you want to use, and then the application you want to run, so that it's basically running it inside a shell of its own that has the kind of correct paths, so that it finds it as if it was at its normal locations.
Right, so it's just changing the environment.
Essentially, yeah.
Try to organize your questions by row.
You
I don't even know why I got up at 6:30 this morning to go to the fitness center at the hotel.
I'd like to ask how security updates are propagated to containerized applications in software collections. So say I have a Ruby software collection, and Ruby depends on some library that got a security update upstream. Does it mean that the maintainer of the collection will have to update it manually? And if I have like 5 collections which depend on this library, does it mean that 5 different people will have to update their collections to include the update?
Exactly. Yeah, that's the problem. Not if you do dependencies, right? So, like I said, if you use kind of, like, let's say you had a Rails 3 and a Rails 4, both dependent on the Ruby 1.9 software collection, and the the security update happened in the Ruby one, you wouldn't have to update the Rails ones. In theory, I mean, one of the things that I like about software collections is it kind of also lets you, well, I don't know, but it also lets you defend kind of your QA problem, right? So one of the reasons that the enterprise doesn't want to upgrade, often it may be that they expect the code to completely work, but they don't want to test it, right? QA resources are often the ones that you have the least of in any organization. It's often the constraint at any engineering organization I've ever worked with that keeps features from happening. And so when you're doing, again, kind of talking about that janky old app that is just running and doing its thing, why would you want to waste that very limited resource of your QA people to test the upgrade? So I also would hope that I guess I kind of expect that in a particular enterprise, much like I would kind of expect with OpenShift, is like in a particular enterprise, I would kind of expect them to build their own software collections for use in-house. Probably, hopefully, right, dependent on, for a large percentage, 95% of the functionality on somebody else, right? So like on Red Hat or on the community in general or on something. But that they would have their own one so that they could be confident that the API layer at the top is what they expect completely for the applications that they're building. It does 2 things. One, it gives them more kind of tolerance for moving across versions, but then it also does that kind of opposite effect, which then you can still control your developers by saying, here is the approved Ruby software collection, right? Here is the approved Python software collection. Don't go installing random other stuff unless it's made it into the software collection. Oh, one back there.
Yeah, I have a question on how this SCL enable works. So can I use multiple of these environments at the same time? And so will it sort of only map this for this one process with something like proot or mount bind, or how does it get into the environment?
Yeah, it's so you separate them by a space, right? But you can just kind of list out multiple ones that you want. And it's not that cool. It's just paths, right? This is not, chrooting, some brand new file system or something and running in that context. There's no security here, right? None of that stuff. This is just to provide the environment that is kind of so when you make a function call, you get the right binary. That's it.
Yeah, so what is like the lowest level of libraries that you include? For example, these packages, would they include libc, or do you still expect that from the distribution itself?
The package maintainer needs to decide that. And everything that you don't include makes you less portable, right? But makes it so that you have less of the problem that he was talking about back there of massive redistribution updates.
Yeah, but I think it's hard to know like all the pieces that you need. So I wouldn't even know, like if I need Apache, I wouldn't even know all the libraries that it uses. So.
Well, I mean, there's the one aspect of you need to know what libraries you care about, right? But then there's the other aspect of where's this fine line of how much stuff to include. I think we're still struggling with that too. I think, I don't think there is, well, I don't think there will ever be a silver bullet kind of answer. What we're trying to do is do a better job of documenting how to think about it. And there are starting to be a lot of examples, right? So now we have whatever, 10 or 12 that we're shipping. There's there's at least another 5 or 10 that I know about kind of in the software world. So there's starting to be examples that are making decisions. I think we're also going to run into problems. It's really nice actually that RHEL 7's kind of on its way out the door, because that'll be the first test of some of this stuff. So, I'm running the beta here. And so but it's only been like a couple weeks. So what I want to do is start to try to take an application that I wrote on the software collection for Ruby on RHEL 6, run that hopefully unchanged on RHEL 7, and then I actually want to be able to run the same thing unchanged on OpenShift. Because OpenShift actually uses software collections that's how it delivers those blobs as well. Did I see a question over here? Yeah. No, he's first, then you, because that way he can keep walking in the right direction. Oh.
She raised me.
Thank you. So I'm no advanced coder. I'm not a coder at all, but I'm aware of distributions and dependencies and versions and stuff. And I just want to understand correctly what this means. So you say I can make a package of a software and include my own dependencies, what I need, and do it all into the opt system. And all I need to do to make this work in any distribution is to insert this SCL trick. Is that about correctly?
So it's a little more complicated than that. So the first part is you have to create the thing, right? So you have to have your application and all its dependencies, and then you have to shove that all into some sort of package. In the case that I'm talking about, that's all RPM. Then on deployment, so on install of the application is where the ops stuff comes in. So it's where it's going to show up. And then this kind of SCL stuff works, because basically now you have all of the pieces that you need. Some of it might be coming from the operating system itself. Some of it might be coming from this set of packages called the software collection to actually deliver the API for, say, Ruby to another application, right? So we expect, and I know of a couple of companies that are doing this, but we expect that some companies will kind of, whether it's open source or proprietary, they're going to actually create their own application as a software collection, which will then have a dependent collection that they also carry, or set of dependent collections, so that then the whole thing will kind of get installed there. But then you'll have that, so when you install, X, Y, and Z software, you actually get that whole collection from them, and including any dependent collections that they may get from elsewhere.
So every package brings its own. So every package brings its own environment completely.
Right. So it may rely on some stuff that's in the OS too, or it may not. It's up to the package or the collection.
Okay. My question is: are you aware of Nix and Gwix package managers? Because they are doing similar job, but I believe slightly better and without RPM.
So as I said kind of on that earlier slides, like everybody has had this problem a ton, all the time, right? Microsoft has a solution for this problem as well. This, I don't know if you guys know anything about .NET, but one of the major changes, you may have remembered the advertising was, .NET solved DLL hell, right? And the way it did that was having this thing called the global cache and then a per application cache. And what ended up happening, they had this magical, mystical idea that in the global cache would be, things like glibc. What in fact happened is that every single application that got installed picked up their own, right? Mac has always, and to the best of my knowledge, and I don't know a whole lot about Mac packaging, but Mac has pretty much always worked this way, in that every application basically carries its entire dependency tree every time you install it. So, it's not limited to Linux, number one, and it's certainly not limited to the examples I gave. I don't actually know the one you mentioned, so I'll go ask Google.
Okay, and another thing, I didn't understand that what are the new demands for software vendors to be able to use this?
Well, so it's really just a style. It's a way of saying, hey, this is a way you could deliver your application that, because this happens to be RPM, right? But the same concept could work in anything. Right? It doesn't really matter that much. You just need kind of something like Yum to manage where they're coming from and getting updates. But I think a software vendor of some kind could say, hey, here's a way to distribute it, and it might be easier for you to build the packages for, let's say, Enterprise Linux 4, 5, and 6. They might be able to find a way to create a software collection that will install on all of them, right? So that they don't have to recertify for every minor version, right? That they don't have to, they can also deploy on Fedora, even though Fedora is way ahead of RHEL, right? Does that make sense? Arguably.
So I've got a question on, I suppose this goes back to how big the software collections are, but say you have a software collection for different versions of Rails and you have software collections for different versions of Ruby. Is this to suggest that for every permutation you want, you would then need to build another independent software collection on top of that?
Theoretically, right. So theoretically, that's the struggle, right, is where do you want to draw that line? So right now, for example, the one we built, right, this Ruby 193 actually includes Rails 3 as well. So even though it's called Ruby 193, there's actually, I don't know, 40, 30, some number of gems in there. I can't remember how many, but a whole bunch, right? Which if I read Ruby 193, I don't hear gems, right? So I'm not sure that we're entirely happy with that choice, that maybe Rails should have been separate, because then it would have been easier for us to say, okay, now we have a Rails 3 software collection and a Rails 4 software collection, both dependent on the Ruby 193 software collection.
Maybe I missed it when I was just looking at my phone during your talk or whatever. Sorry about that.
Thanks, Don.
I'm curious about some of the details. Like how do people actually create these collections? How do they deliver them to users? How do users install them, and how do they manage them? What do the tools look like in practice?
So I was going to include some of the macros, but I decided not to. But basically, when you're writing an RPM, right, you have this big thing called a spec file, which kind of describes what's in the RPM, right? In that spec file, we just add some new macros that indicate that this is a software collection and that it's going to go kind of in a special place. And that's about it as far as the difference. One thing that was kind of a design goal was that the same spec file, if it knew about software collections, could also be built to not be a software collection. So hopefully what'll happen is that all spec files everywhere, right, will have kind of the support for a software collection, so you could build it that way, or decide to not build it that way, depending on your use case. And then as far as the tools are concerned, it's just yum install, X, Y, and Z, software collection.rpm, whatever it happens to be called. In Enterprise Linux, you have to add what's called a channel, which don't get me started on that. But basically, you have to add another repo coming from Red Hat, and it's got a bunch of them in there. You just say yum install blah blah blah. I think CentOS, they're mainlined. Did they make it to mainline, or are they still in test? They are, okay. So in CentOS, you can actually just log in, yum install Ruby 193. So it's all the tools you're already familiar with for the most part. They'll work just like RPM does with Puppet. So it has also all the failings of RPM, but it's easy.
Hi. Do you have an example yet of an application that's packaged in the normal places, like where a user would expect them, but it depends on an SCL? So, for example, the user would run the application where it normally is, has never seen the SCL enable utility, but the application then enables the SCL it requires itself.
Sort of. Basically, so I've done that with like HTTPD, right? So, to get the web server to use the Ruby 193 stuff, I need to kind of modify its start script. And I was, for that particular example, I was using the native Apache web server rather than a software collection. I think we want to be mildly careful of that because that's one of my fears, is that if you have something that is distributed by the normal OS that's dependent on a software collection, that might be weird. It's it kind of goes out of the user's, or when I say user here, right, the system administrator or developer's expectation of where stuff is going to show up. Where to go find.
So my assumption is it's distributed separately in a separate Yum repo, even maybe with an SCL. But when a user installs it, the application appears in its normal places, but it's using an SCL behind the scenes.
Exactly. So that's exactly what I did for like HTTPD. Do it if you want to set up a batch profile that it just runs, right? However, in general, if I had kind of a real top-level application, my cool website that runs in your office, I would rather that people package that as a software collection, and then
why?
It's dependent on software collection. I think user expectation. I think having a shell script or something that's kind of off in a more normal place that points at it is fine. But I don't know. I guess I don't like if an application installs under opt, then it shouldn't touch the rest of the OS. Right? If I choose to make it touch the rest of the OS, so a Calibre installs, if you install it from the Python script, it installs under opt. It doesn't touch the normal operating system basically at all. But I can put a symlink to it from user bin. Right?
Pass it up to that gentleman.
Sorry, just one technical add. There's no reason you can't. It's just that's my preference.
Well, I don't know if you have already answered my question, but it's another twist on the situation. Let's say we have a Ruby collection or a Python collection, and I want to add a particular gem or Python module. I know how to create a packet for a native environment. Can it be easily added to the existing collection? Do I have to create a new collection and overwrite or remove the previous one?
Right. So that's actually exactly the problem. In some ways, we didn't really talk about it here, but the other thing that a dependent collection could or should be able to do, right, is we're talking about, we have the Ruby collection, which this one happens to include Rails, right? So let's say I want to write a dependent collection that swaps swaps Rails 3 and puts in Rails 4. Well, we don't want you to have to rebuild this one, right? So what we'd like, one of the things that we're working on I think it's more of a documentation problem. Hopefully it's not a bug problem, but there's a documentation problem to say, okay, how do you write a dependent collection that swaps part of a collection, right? And does that make sense, or is that completely insane?
I've got a question. Does the software collection packages run independently from each other? Means if I run two at the same time, which have got a dependency inside which breaks if they run at the same time, do they run independent of each other?
So I was kind of saying that earlier. You can kind of. So I had an example where I was doing. I think it was Postgres. So we have a Postgres software collection. So I had an app that used Postgres, 9 something that we're shipping, and Ruby 1.9. So what I do here is I kind of say SCL enable Ruby 1.9 space Postgres bash. Okay, so that gives them both there. If there's a dependency between the two, then I think you should have a software collection that is dependent on the two, and then you use that software collection, if you follow me. So in the Rails, Ruby and Rails example, I wouldn't kind of run them both. I would have built the Rails one such that it's dependent, and then I would SCL enable Rails for Bash. Yes, and it's just that one depends on the other, rather than using both. The only time I would use both is because for my application, I need 2, 3, 4 different pieces of software, Postgres, Memcached, and Ruby.
Okay. We have time for this one and one more. So the next question goes to whoever's going to go get me a beer after the question.
In the Red Hat developer blog, there was this topic 1 year ago. And compared to this, what's the news?
Not a lot. Like I said, I actually what I do think we've found, like kind of over the course of, software collections have been now around almost 3 years. So what I think we're finding, particularly since we started shipping some stuff, whatever, a year and change ago, is the problems people run into. So like this dependent collection problem. And so, getting real world use, starts to poke some of the holes in it. I think the other big stuff that's changing is, like I said, containerization is already hugely important and becoming way more important. And how that integrates with packaging, I think, is also going to be a really interesting ride.
Is there any project page or something where the community can...
Coming soon.
Yeah, let's just say I would really, really like there to be kind of a proper upstream for kind of software collections as a concept. It is all open source, but it's kind of like all over the place. So while it's open source, there's no practical means of finding it all, right? Unless you work with the CentOS guys and have this magic ability to find things. So one of the things that we have in the works is to try to get kind of a landing place for software collections as a whole. And we've heard from people about the software collections that they've built that they would like other people to be able to use. And so kind of allow for a community to form around it. Everybody's got lots of things to do.
Any other questions? Apparently no one wants to give me a beer. All right, thanks, Langdon.
You're welcome.